Imagine looking at a plain yellow flower. But to a tiny creature nearby, that same flower is a glowing, psychedelic landing strip covered in secret patterns and shimmering with a light you can't even comprehend. Today, we're peeling back the curtain on the unseen world, exploring the incredible ways animals see things that are completely invisible to us. If you're ready to have your mind blown, hit that subscribe button and let's get started. Let's start with that flower. For you, it's yellow. For a bee, it's a whole different story. That's because bees can see in the ultraviolet spectrum, a range of light that is completely invisible to the human eye. Many flowers have evolved to take advantage of this, developing intricate ultraviolet patterns called nectar guides. These hidden markings act like airport landing lights, guiding the bee directly to the pollen and nectar. To a bee, a seemingly plain sunflower actually has a dark, absorbing center and brightly glowing tips in UV light. A dandelion transforms into a perfect ultraviolet bullseye. This amazing ability allows bees to find their food source with incredible efficiency, but it's a dangerous world. Some spiders have learned to exploit this superpower, weaving UV-reflecting silk into their webs to lure in unsuspecting bees looking for a flower. And bees aren't alone. Butterflies can also see UV light. Their beautiful wings, already masterpieces to us, contain hidden patterns and markings only visible in ultraviolet. These secret signals are crucial for finding and attracting a mate. This UV vision isn't just for insects. Up in the frozen Arctic, reindeer also see an ultraviolet, and for them, it's a matter of life and death. You see, snow reflects UV light intensely, creating a blinding whiteout. But the reindeer's main food source, lichen, absorbs UV light. This makes the lichen stand out as dark, easy-to-spot patches against the bright snow. It also helps them spot danger. A predator, like a wolf, has fur that absorbs UV, making it appear as a dark silhouette against the landscape, giving the reindeer a critical head start. In a truly wild adaptation, a reindeer's eyes actually change color with the seasons. In the bright summer, their eyes are a beautiful golden color. But during the long, dark Arctic winter, they shift to a deep blue. This remarkable change scatters more light within the eye, making them significantly more sensitive in the low-light conditions. Which flower do you think looks the most different in ultraviolet light? Let me know your guess in the comments. Now, if you think UV vision is cool, let's dive into the ocean and meet the undisputed king of eyesight, the mantis shrimp. This little creature has, without a doubt, the most complex eyes in the entire animal kingdom. To put it in perspective, we humans have 3 types of color-receptive cones in our eyes. Our dogs have 2. The mantis shrimp has between 12 and 16. That means they can perceive a world of colors that we literally cannot even imagine. On top of that, they can also see both ultraviolet and infrared light. Their eyes are mounted on stalks, and each one can move independently. But here's where it gets truly bizarre. Each individual eye has trinocular vision. That means a single eye can perceive depth and distance all on its own. We need 2 eyes working together to do that. But the mantis shrimp's most legendary power is its ability to see polarized light. They can detect both linear and circular polarized light, something no other animal is known to do, and which is totally invisible to us. This helps them cut through the glare of the water to spot otherwise transparent or silvery prey. It's also their secret language. They can reflect polarized light off their bodies to communicate with other mantis shrimp, sending messages that are completely invisible to any potential predators. Speaking of polarization, let's look at the cuttlefish. Here's a paradox for you. Cuttlefish are masters of camouflage, able to change their skin to perfectly match the color and texture of their surroundings in less than a second. But they're colorblind. They only have one type of photoreceptor. So how do they do it? The answer, again, is polarized light. Their strange W-shaped pupils give them an enhanced ability to perceive the polarization of light as it reflects off different surfaces. This provides a ton of information about texture and contrast, which they use to create their unbelievable camouflage. Their cousins, the octopuses, are also colorblind but share this ability to see polarized light. Their unique rectangular pupils help them control the amount of light entering their eye, which is a huge advantage in their varied environments. And some scientists even believe an octopus's skin can directly sense light, helping them fine-tune their camouflage without even looking. If you could see polarized light like a cuttlefish, what's the first thing you'd want to look at? Drop your ideas below. From the ocean to the desert floor, snakes have a different kind of secret vision. Pit vipers, like rattlesnakes, have a true superpower, thermal vision. They possess special heat-sensing organs called pit organs, located between their eyes and nostrils. These pits are so sensitive, they can detect temperature differences of as little as 0.003 degrees Celsius. This allows them to literally see the body heat of their warm-blooded prey. For the snake, this thermal information is overlaid on top of the normal visual information from its eyes, creating a fused image of light and heat. It's a biological thermal scope. And because it relies on heat, not light, it works perfectly in complete darkness, making them devastatingly effective nighttime hunters. Other snakes, like boas and pythons, have similar, though less advanced, heat-sensing pits arranged along their jaws. Of course, we can't talk about super eyes without looking to the sky. The eyesight of an eagle is legendary for a reason. An eagle can spot a rabbit from over 3 kilometers away. Their vision is estimated to be up to 8 times stronger than ours. This power comes from the sheer density of photoreceptors in their retinas. We have about 200,000 cones per square millimeter. An eagle has over 1 million. They also have a secret weapon, 2 fovea, or centers of focus, in each eye. One looks straight ahead, providing sharp, binocular vision. The other is angled to the side for perfect peripheral monocular vision. This means an eagle can be focused on a mouse directly in front of it and simultaneously scan the horizon for other threats, all in perfect clarity. And like bees, many birds, such as the kestrel, can see in the ultraviolet spectrum. This isn't for seeing flowers, though. Kestrels use their UV vision to hunt voles by spotting the ultraviolet light reflected from their urine trails. What other animal superpower do you find the most fascinating? I'd love to read your answers. But for sheer visual processing power, it's hard to beat a dragonfly. Their enormous compound eyes can cover almost their entire head, giving them a nearly 360-degree field of view. Each of these giant eyes is made up to 30,000 individual lenses called ommatidia. Each tiny lens captures one piece of the puzzle, and the dragonfly's brain stitches it all together into a comprehensive mosaic image. But their real trick is speed. Dragonflies essentially see the world in slow motion. Their eyes can process information at up to 200 frames per second. Humans top out at around 60. This incredible processing speed makes them one of the world's most successful aerial hunters, allowing them to calculate and predict the flight path of their prey with a staggering 95% accuracy. As we go deeper into the crushing blackness of the deep ocean, vision gets truly alien. The barrel-eye fish has one of the strangest visual systems on the planet. It has a completely transparent head filled with fluid. Its eyes are 2 green, light-sensitive orbs located inside its head. These barrel-shaped eyes typically point straight up, scanning the water above for the faint silhouettes of prey. But incredibly, the fish can also rotate them to look straight forward. Most deep-sea animals can't see color, but they are exceptionally good at seeing shades of blue, since blue light is the last color to disappear in the deep water. And for sheer size, nothing beats the colossal squid. It has the largest eyes of any animal on Earth, each one the size of a dinner plate. These massive orbs aren't for seeing in the sunlit world. They're designed to capture the faintest glimmers of bioluminescence from prey in the total darkness. Then there's the cockeyed squid, which has one big eye and one small one. The large eye looks up for silhouettes against the faint light from the surface, while the smaller eye looks down, searching for bioluminescent flashes from below. If you were designing a deep-sea creature, what kind of crazy eyes would you give it? Describe your creation in the comments. The world is full of these visual wonders. A chameleon's eyes can move independently of each other, allowing it to look in two completely different directions at once for a full 360-degree view without moving its head. And the four-eyed fish doesn't actually have four eyes. Instead, its two eyes are split in half by a band of tissue, with the top half adapted for seeing above the water's surface and the bottom half adapted for seeing below it simultaneously. From colors we can't see to light we can't comprehend, the world looks incredibly different depending on who is doing the looking. If you enjoyed seeing the world through a new set of eyes, make sure to like this video and subscribe for more amazing facts about the animal kingdom. Thanks for watching. What if I told you that for most animals on Earth, the real world only begins after the sun goes down? Let's stalk through the shadows and uncover the secrets of animals who own the night. When your car's headlights catch a pair of glowing eyes on a dark road, you're witnessing one of nature's most brilliant inventions. That eerie, otherworldly glow is called eyeshine, and it's the secret sauce for nocturnal hunters. It's produced by a structure called the tapetum lucidum, which is essentially a biological mirror positioned right behind the retina. Think of it like this. When light enters the eye of an animal, like a cat or a raccoon, it hits the light-sensing cells of the retina once. But instead of being absorbed by the back of the eye, like in our own vision, any light that gets missed is bounced off the tapetum lucidum and sent back through the retina for a second chance. It's an incredible light recycling system, effectively doubling the amount of available light and allowing these creatures to see with stunning clarity in what we would consider near total darkness. The color of the eyeshine itself, be it green, blue, yellow, or even red, depends on the specific minerals that make up this reflective layer, like zinc or riboflavin, creating a unique signature for different species prowling the night. Now, if a cat's eye is a well-designed flashlight, the tarsiers' eyes are full-blown searchlights. This tiny primate, found in the rainforests of Southeast Asia, holds a Guinness World Record it probably doesn't even know about. It has the largest eyes relative to its body size of any mammal. Each one of its eyeballs is as large as its entire brain, and together they can weigh more than its brain. They are so massive, in fact, that the tarsier can't even move them in their sockets. Instead, just like an owl, it has to turn its entire head, able to rotate it a full 180 degrees in each direction to scan its surroundings for insects and small lizards. This fixed gaze system means it has phenomenal depth perception, which is crucial for a creature that spends its life leaping from branch to branch in the dark. It's a truly extreme adaptation, a case of evolution going all in on a single sensory tool. Have you ever been lucky enough to see a tarsier in person? Their eyes are unforgettable. If you have, tell me about it in the comments below. Speaking of owls, they are the undisputed kings of the nocturnal sky, and their visual system is a masterpiece of low-light engineering. An owl's eyes aren't spherical like ours. They're more like elongated tubes held in place by bony structures called sclerotic rings. This shape allows for a much larger cornea and lens at the front, acting like a massive light-gathering funnel. But the real magic is on the inside. Their retinas are absolutely packed with light-sensitive rod cells, sometimes at a density of 1 million per square millimeter. To put that in perspective, humans have about 200,000 in the same amount of space. This overwhelming number of rods gives them a sensitivity to light that is estimated to be up to 100 times greater than ours. The trade-off? They have very few cone cells, which are responsible for color vision. So while they can spot a mouse scurrying in the grass under the light of a single star, their world is likely painted almost entirely in shades of gray. If you could borrow one animal's night vision for a single night, which would you choose and why? Let me know your pick down in the comments. But what happens when you go somewhere with no light at all? I'm talking about the crushing, absolute blackness of the deep ocean. Here, some creatures have evolved a truly wild solution. They don't just see in the dark, they make the light. Take the incredible stoplight loosejaw fish. Like many deep-sea dwellers, it can produce blue-green bioluminescence to attract prey. But it has a secret weapon. It is one of the only fish in the world that can also produce and see red light. Most creatures in the deep sea have evolved to see blue light as it travels farthest in water, meaning they are completely blind to red wavelengths. The loosejaw uses this to its advantage, casting a beam of red light from a special organ under its eye that acts as a private, invisible sniper scope. It can illuminate its unsuspecting prey, which remains completely oblivious, caught in a spotlight that it literally cannot see. It's the ultimate stealth hunting technology, cooked up by nature in the most extreme environment on Earth. Back on solid ground, let's look at a creature you might find on your own wall, the gecko. These little lizards have some of the most remarkable night vision in the entire animal kingdom. While we stumble around in the moonlight, seeing only faint outlines, a gecko sees the world in vivid color. Their eyes are an evolutionary marvel, about 350 times more sensitive to light than our own. Unlike owls, who sacrificed color for sensitivity, geckos manage to have both. Their secret lies in their cone cells, the ones we use for color vision. The gecko's cones are much larger and more sensitive than ours, and they're arranged in distinct concentric zones. This unique structure allows each zone to focus on different wavelengths of light, essentially creating a multifocal, full-color night vision system. They can distinguish between blues, greens, and even UV light in conditions so dim they would appear monochromatic to us. It's like having military-grade night vision goggles that also see in high-definition color built right into your head. Of course, not all night vision requires eyes. Some creatures have developed a sense so alien it's hard for us to even comprehend. Pit vipers, like rattlesnakes and copperheads, have a terrifyingly effective way of tracking their prey in total darkness. They have a pair of special organs, or pits, located between their eyes and nostrils. These pits are not eyes. They are highly sophisticated infrared detectors, packed with heat-sensitive nerve endings. They can detect temperature differences of as little as 0.003 degrees Celsius. This allows the snake to build a thermal image of its surroundings. It can see the heat signature of a warm-blooded mouse against the cool background of the forest floor as a glowing three-dimensional shape. What's even more mind-blowing is that the snake's brain integrates this thermal data with the visual information from its actual eyes, creating a fused, multi-sensory map of reality. It's like having a thermal scope overlaid onto your regular vision, allowing it to strike with pinpoint accuracy in pitch black. It's a fascinating ability, but here's a question for you. Do you think this thermal sense truly counts as a type of vision? I'm genuinely curious what you think. Drop your opinion in the comments. Finally, we can't talk about the night without mentioning one of its most common flyers, the moth. While we might dismiss them as they flutter around a porch light, their eyes are astonishingly powerful pieces of natural technology. A moth's compound eyes are built for one thing: maximizing every single photon of available light. They use a design called a superposition eye. In this system, the light collected by several individual lenses, or facets, is channeled and focused onto a single photoreceptor cell. It's like having hundreds of tiny telescopes all pointing at the same spot, amplifying the faintest glimmer of starlight into a usable image. This optical superposition makes their eyes incredibly sensitive, allowing them to navigate complex environments using celestial cues. In fact, that famous attraction to artificial lights is likely because they mistake the bulb for the moon, their primary navigational beacon, and try to keep it at a constant angle, resulting in that spiraling, doomed flight path. What's the most fascinating thing you've ever watched an animal do at night? Share your story below. From mirrored eyes to infrared heat maps, the night is anything but dark for those equipped to see it. Imagine seeing everything at once, not just what's in front of you, but what's beside you, behind you, and even above you, all at the same time without ever turning your head. Well, for some animals, that's not imagination, it's just another Tuesday. We're about to explore the world through the ultimate wide-angle lens, where a 360-degree view is the ultimate survival tool. For a chameleon, reality is a bizarre split-screen experience. Its two eyes are perched on conical turrets that can rotate and focus completely independently of each other. This is not a party trick. It's a mastery of visual multitasking. One eye can be scanning the leaves above for a juicy insect, while the other is simultaneously pointed backwards, vigilantly watching for a snake or a bird of prey. This gives the chameleon a staggering 360-degree field of vision. It literally sees the entire world around its body as a complete sphere of awareness. There are almost no blind spots. But here's the truly amazing part. When it finally spots a meal, its brain instantly snaps both eyes forward. They lock on to the target, switching from two separate panoramic views to a single, powerful binocular vision. This allows it to judge distance with pinpoint accuracy, a crucial skill before it launches its famously long and sticky tongue. It's like having two independent reconnaissance drones that can merge into a single, high-powered sniper scope at a moment's notice. From the world of reptiles to the vast open plains, another master of panoramic sight takes a very different approach. The horse possesses the largest eyes of any land mammal, each one about the size of a human eyeball, but they are positioned on the sides of its head. This placement isn't for show. It creates a visual field that wraps almost completely around its body, covering nearly 350 degrees. A horse can see you approach from its side or even from its rear flank without so much as twitching an ear. This leaves it with only two small blind spots, a narrow cone directly in front of its nose and a thin sliver directly behind its tail. You may have noticed a horse raising or lowering its head to look at things at different distances. That's not just curiosity. Because of the shape of its retina, it has to physically tilt its head to bring objects into focus, essentially using its entire neck as a manual focus ring for its built-in wide-angle lenses. But as impressive as the horse is, if you want to see the absolute pinnacle of panoramic prey animal vision, you have to look at the humble rabbit. Rabbits have taken this eyes on the side of the head strategy to its logical extreme. Their eyes are placed so high and so far to the sides of their skull that their field of vision is a near perfect 360 degrees. Think about that. A rabbit sitting perfectly still in a field can see a fox approaching from the left, a hawk circling overhead, and a person trying to sneak up from behind, all at the same time. Its only blind spot is a tiny patch of space right on the tip of its own nose. This is why you can sometimes get very close to a rabbit from the front. It literally can't see you in that final foot of approach. This system sacrifices the sharp, forward-facing depth perception that predators need, but in exchange, it gets something far more valuable for a professional meal in waiting: near total situational awareness. If you could have panoramic vision but had to give up sharp forward-facing focus, would you take the trade? Let me know your survival strategy in the comments. Now, let's dive beneath the waves, where a panoramic view can mean the difference between hunting and being hunted. The hammerhead shark is instantly recognizable for its bizarrely shaped head, known as a cephalofoil. For years, scientists debated its purpose, but we now know it's a visual marvel. Spacing the eyes out at the ends of the hammer does two incredible things. First, it gives the shark exceptional binocular vision and depth perception, far better than its pointy-nosed cousins. But even more mind-blowing is its vertical field of view. By placing its eyes on the sides of a wide, flattened surface, the hammerhead achieves a full 360-degree view on the vertical plane. It can see directly above its head and directly below its body simultaneously. As it swims along, it swings its head from side to side in a sweeping motion, using this incredible vision to scan the entire seafloor for the faint electrical signals of stingrays buried in the sand, its favorite food, while also keeping an eye on the water above. From the ocean's giants, we move to a tiny terror of the skies whose visual system is pure science fiction. The dragonfly's head is almost entirely dominated by two massive compound eyes, which are themselves made up of up to 30,000 individual microscopic lenses called ommatidia. Each tiny lens captures its own sliver of the world, and the dragonfly's brain stitches these tens of thousands of images together into a single, seamless mosaic of its surroundings. The result is a perfect 360-degree field of vision. A dragonfly can see forwards, backwards, up, down, and to both sides all at once. This is a huge part of why they are such notoriously difficult insects to swat. But it gets better. Their brains process this visual information at a speed that makes our own look like it's running on dial-up. For a dragonfly, the world moves in a kind of super slow motion, allowing it to calculate the trajectory of a tiny net, intercept it in midair, and adjust for wind speed, all in the blink of a human eye. Of course, not all panoramic vision belongs to creatures that move. Let's look at an animal you'd probably never guess even has eyes in the first place: the scallop. Along the edge of a scallop's shell, where the two halves meet, is a row of up to 200 tiny, iridescent blue dots. Those are its eyes. And they are not simple light-sensing pits. Each eye is a miniature marvel of biological engineering, operating on a principle completely alien to our own vision. Instead of a lens that focuses light, a scallop's eye uses a concave mirror made of guanine crystals, like a tiny reflecting telescope. This mirror focuses light onto not one, but two separate retinas. One retina is specialized to detect light and movement in the periphery, while the other is tuned to see what's more centered. This setup is brilliant at detecting moving shadows and shapes, giving the entire colony of eyes a wide-angle view that instantly alerts the scallop to an approaching starfish, allowing it to snap its shell shut or even propel itself away by clapping its shells together. Finally, we return to land to witness an animal whose eyes are, quite literally, bigger than its brain. The ostrich holds the record for the largest eyes of any land animal on Earth. Each eye is about 2 inches in diameter, roughly the size of a billiard ball. They are so massive that there is little room left in the ostrich's skull for anything else, including its brain. But these giant organs are no vanity project. Set on the sides of its head, they provide an immense panoramic view of the open savanna. But unlike a rabbit, they also have a significant area of binocular vision, allowing them to judge distance as well. This combination of wide-angle awareness and long-distance clarity is a formidable defense. An ostrich can spot a predator like a lion from over 2 miles away, giving it a massive head start to either run, which it does at incredible speeds, or prepare to defend itself with its lethally powerful kicks. It's a visual system that proves in the wild sometimes the best offense truly is a spectacular defense. What if I told you the world is covered in secret messages, painted in brilliant colors that you are completely blind to? Well, for countless animals, this invisible world is their everyday reality. Let's start in your own backyard. You see a bee buzzing around a flower, maybe a plain yellow dandelion. To you, it's just a yellow dot. But to that bee, it's a dazzling, psychedelic masterpiece. Bees have what's called trichromatic vision, just like us, meaning they have 3 types of color-receptive cones in their eyes. But here's the twist. Where our cones are tuned to red, green, and blue, a bee's are tuned to blue, green, and ultraviolet. This means they can't really see the color red. It just looks like a dark, muted shade to them. But in its place, they see a color we can't even imagine: ultraviolet. This superpower isn't just for fun, it's for survival. Flowers have evolved alongside them, creating stunning, intricate patterns on their petals that are only visible in UV light. We call these patterns nectar guides, and they act like glowing neon landing strips, pointing the bee directly to the sweet reward of nectar and pollen. That simple yellow dandelion? To a bee, it has a brilliant ultraviolet bullseye right in the center. It's a secret language written in light, a partnership between plant and insect that has been perfected over millions of years. And their UV vision has another incredible use. It allows them to see patterns of polarized light in the sky, which they use as a celestial compass to navigate back to the hive, even on a completely overcast day. This ability to see the world's hidden UV layer isn't just for finding flowers. For some, it's about finding a meal. Take the kestrel, a beautiful little falcon you might see hovering over a field. It seems impossibly still, scanning the ground with an intensity that's almost unnerving. You might think it's just looking for movement, but its real secret is far more clever. Kestrels can also see in the ultraviolet spectrum. So why does that matter? Well, small rodents like voles, a kestrel's favorite snack, constantly mark their territory with urine. And it just so happens that vole urine absorbs ultraviolet light. The surrounding grass, rocks, and soil reflect it. This means that to a kestrel circling high above, the crisscrossing trails and burrows of a vole colony glow like dark, intricate highways against a bright background. They're literally following a glowing pea map to their next meal. If you could have one animal's vision for a day, which would it be and why? Let me know in the comments below. From a hunter in the sky, let's dive deep beneath the waves to meet the undisputed king of color vision, the mantis shrimp. To say its eyes are complex is a wild understatement. While we have our humble 3 color-receptive cones, the mantis shrimp has, get this, between 12 and 16 of them. That's not a typo, 12 to 16. Scientists call this dodecachromacy, and we can't even begin to process what that must look like. They don't just see more shades of our colors, they see into the ultraviolet spectrum and beyond. But it gets even crazier. They can also see polarized light, light waves that are all oriented in the same direction. We need special sunglasses to do that. The mantis shrimp can not only see it, but they can differentiate between linearly polarized light and circularly polarized light, something no other animal is known to do. This gives them a secret communication channel. They have special patches on their bodies that reflect polarized light, allowing them to flash messages to each other that are completely invisible to any predator or prey nearby. And their eyes themselves are a biological marvel. They sit on stalks and can move independently of one another. Even weirder, each individual eye has 3 separate regions that focus on the same point, giving it trinocular vision. With 2 eyes, this creature has hexnocular depth perception. It's seeing the world in a way so alien and complex, it's almost beyond our comprehension. Now, that might be hard to wrap your head around, so let's travel from the complex chaos of a coral reef to the stark, simple white of the Arctic. Imagine you're a reindeer, and for months on end, your entire world is white snow, white sky, white everything. Finding food or spotting a predator would seem impossible. But reindeer have a trick up their sleeve, or rather, in their eyes. Their vision actually changes with the seasons, but the crucial adaptation is their ability to see ultraviolet light. Why is this a game changer in a world of white? Because fresh snow is one of the most UV reflective surfaces on Earth, creating a blinding glare in that spectrum. But the things a reindeer needs to see, like lichen, their primary food source hidden under the snow, or the fur of a predator like a wolf, are excellent absorbers of UV light. So, against a painfully bright UV backdrop, their food and their enemies appear as stark, dark silhouettes. They've evolved to see the life-saving contrast in a landscape that, to our eyes, is a featureless whiteout. What's the most surprising place you've ever seen an animal? Drop your story below. This UV superpower is incredibly common in the animal kingdom, especially among birds. In fact, most birds are tetrachromats. They have the red, green, and blue cones we have, plus a 4th one dedicated entirely to ultraviolet. This opens up a whole new dimension of color that they use for everything, especially for finding a mate. A bird that looks a bit plain to us could be a shimmering beacon of ultraviolet beauty to another bird. The classic example is the blue tit. That little patch of blue on its head seems nice enough to us, but in the ultraviolet spectrum, it glows with an incredible, vibrant intensity. The brightness of that UV glow is a direct signal of the bird's health and genetic fitness, making the most brilliant birds the most desirable partners. It's like a secret, flashy status symbol. This UV vision even helps them be better parents. The eggs of some bird species, which might look like plain speckled eggs to us, are covered in unique ultraviolet patterns. These patterns allow the parent to instantly recognize their own eggs, which is critical for spotting a foreign egg laid by a brood parasite, like a cuckoo. What's an animal fact you learned recently that just completely blew your mind? So far, we focused on ultraviolet light, but some animals have super eyes that see on the opposite end of the invisible spectrum, infrared. Think of pit vipers, like rattlesnakes and copperheads. They don't see infrared with their eyes at all. Instead, they have a pair of remarkable organs called pit organs, located in little indentations between their eyes and nostrils. These pits are packed with tens of thousands of nerve endings that can detect tiny, tiny fluctuations in thermal radiation, or, as we know it, heat. This gives the snake a crude but incredibly effective thermal image of the world, which it overlays on top of the visual information from its regular eyes. In total darkness, a warm-blooded mouse doesn't stand a chance. To the snake, it glows like a bright, mouse-shaped light bulb against a cool, dark background. These pit organs are so sensitive, they can detect temperature changes as small as 0.003 of a degree Celsius. This allows them not only to strike with pinpoint accuracy, but also to follow the fading heat trail left behind by prey that has already scurried past. This hidden world of color and light is everywhere, even on the wings of one of the most delicate creatures. Butterflies, like bees, see in ultraviolet, and they use it to create a world of breathtaking beauty we're completely oblivious to. Their wings are covered in microscopic scales that don't just contain pigment, they have a complex structure that bends and reflects light in specific ways. This structural coloration creates iridescent sheens and, more importantly, secret patterns that are only visible in UV. These patterns are a vital language. A male butterfly can identify a potential mate from a distance just by the unique way her wings flash UV light. These secret signals proclaim their species, their sex, and their readiness to mate, all in a silent, shimmering code that keeps them safe from predators that can't see into that part of the spectrum. If you could design a new color that only you could see, what would you call it? From the heat signature of a mouse in the dark to the glowing landing strips on a flower petal, it's clear that the world we see is just a sliver of the full picture. Our reality, painted in reds, greens, and blues, is just one channel on a television with an infinite number of broadcasts. All around us, animals are tuning in to different frequencies of light, seeing a world of secret messages, hidden pathways, and dazzling beauty that remains, for us, completely invisible. Imagine a color you've never seen. Not a different shade of blue, but a truly new color, as different from red as red is from green. Now, imagine your brain being able to process 12 of them. Today, we're diving deep into the ocean to meet nature's undisputed optical overachiever, the mantis shrimp. This little crustacean, which is neither a mantis nor a shrimp, possesses the most complex visual system ever discovered in the animal kingdom, and it starts with a truly mind-boggling foundation. While you and I perceive the world through just 3 types of color-receptive cone cells, for red, green, and blue, the mantis shrimp doesn't just double or triple that. It boasts a staggering 12 to 16 distinct types of photoreceptor cells. This isn't just a minor upgrade. It's like comparing an old black and white television to a futuristic virtual reality headset that hasn't even been invented yet. Each of these photoreceptors is tuned to a different, specific wavelength of light, giving the mantis shrimp a spectral sensitivity that dwarfs our own. They are literally seeing a world painted in a palette of colors we cannot even begin to comprehend. Think about that for a second. There are entire dimensions of color swirling around in the ocean that are completely invisible to us, but are as plain as day to this tiny, feisty creature. Now, here's where your brain might short-circuit. With all those color channels, you'd assume the mantis shrimp sees a beautifully blended, hyper-colorful rainbow of a world, right? But nature loves a plot twist. Research suggests their brain doesn't actually bother blending all that information together to create a richer picture in the way ours does. That would require an immense amount of processing power. Instead, their system is built for speed and efficiency. They use this vast array of color channels more like a barcode scanner. Their brain instantly recognizes an object or another creature based on its unique multispectral signature without needing to process it deeply. It's not about appreciating the subtle hues of a sunset. It's about making a split-second life-or-death identification of food, predator, or mate with unparalleled speed. It's a completely different philosophy of seeing. Part of this incredible efficiency comes from the physical structure of their eyes, which are themselves marvels of biological engineering. They sit on stalks and can move completely independently of one another. One eye can be looking forward while the other is looking backward. giving them an almost 360-degree view of their surroundings. This eliminates blind spots and means it's practically impossible to sneak up on one. Each eye is like a little surveillance drone, constantly scanning for threats and opportunities from every conceivable angle. But we have to go deeper, because the structure within each eye is where things get truly bizarre. Each of the mantis shrimp's eyes is actually a compound eye, but it's divided into 3 distinct sections: the upper hemisphere, the lower hemisphere, and a central band called the midband. Here's the kicker. Each of these 3 sections can focus on the same point. This means a single eye has trinocular vision. Let me repeat that. You need 2 eyes for binocular vision to perceive depth. A mantis shrimp can perceive depth with just 1 eye, and since it has 2 of these eyes, it effectively has hexnocular vision, 6 overlapping visual fields all working at once. This gives it an incredibly accurate and rapid ability to judge distance and position, which is absolutely crucial for its lightning-fast predatory strikes. As if seeing unimaginable colors and having 3D vision in each eye wasn't enough, the mantis shrimp sees a property of light that is completely invisible to us: polarization. When light waves travel from the sun, they vibrate in all directions. Polarized light is light that vibrates in just one plane. You've experienced this with polarized sunglasses, which block the horizontal glare reflecting off water or roads. The mantis shrimp doesn't need sunglasses. It sees linear polarized light naturally and uses it to its advantage. It's like having a secret filter built directly into your eyes, cutting through the visual noise and glare of the water to see things with stunning clarity. And just when you think it can't get any more advanced, it does. The mantis shrimp is one of the only animals on Earth, and the only one we know of for sure, that can also see circular polarized light. This is a rare form of light where the wave travels in a corkscrew or spiral pattern, either clockwise or counterclockwise. To our eyes, it's indistinguishable from normal light, but to the mantis shrimp, it's a whole other channel of information. This ability is so advanced that most of our own high-tech camera and sensor equipment can't detect it without special filters. If you could suddenly see a new property of light, like circular polarization, what do you think would be the coolest or weirdest thing to look at? Let me know down in the comments below. This elite visual ability isn't just for show, it's a key part of their social life. Many species of mantis shrimp have patches on their bodies, particularly on their legs and tail, that reflect this circular polarized light. This allows them to create secret signals and messages for other mantis shrimp. They can flash warnings, display their fitness to potential mates, or signal their territory, all in a private, encrypted visual language that almost no other creature in the ocean can intercept. It's the ultimate form of covert communication, happening in plain sight, yet remaining completely invisible to predators and prey. Of course, this vision provides a massive advantage in hunting. The mantis shrimp's world is full of things that are either transparent, like the larvae of many sea creatures, or highly reflective and camouflaged, like the silvery scales of a fish. To our eyes, they would blend perfectly into the shimmering, sun-dappled water. But to the mantis shrimp, it's a different story. These near-invisible prey items reflect polarized light differently than the water and sand around them. So, against a background of visual noise, their prey literally lights up, glowing like a neon sign. There is no hiding from an animal that can see your light signature. Their visual spectrum also extends far beyond our own in another direction, into the ultraviolet range. We know that many flowers have UV patterns to guide bees, but this is true underwater as well. Many corals, anemones, and fish have markings that are only visible in UV light. So while we see a reef that is already vibrant and colorful, the mantis shrimp sees an entirely different layer of patterns, signals, and information painted across every surface. This could help them navigate, find specific types of food-rich coral, or identify other animals by their unique UV signatures. Perhaps the most astonishing fact of all is how this creature's alien vision is inspiring cutting-edge human technology that could save lives. Scientists were so fascinated by the mantis shrimp's ability to detect both linear and circular polarized light that they decided to build a camera that could mimic it. In doing so, they made a remarkable discovery. It turns out that cancerous tissue in the human body reflects polarized light differently than healthy tissue. This new mantis shrimp camera can detect these subtle differences, allowing doctors to spot cancerous cells far earlier and more accurately than with the naked eye, especially during surgery. The eye of a small, aggressive ocean crustacean is helping to revolutionize the way we fight one of humanity's deadliest diseases, proving that sometimes the most profound inspiration comes from the most unexpected places. Imagine a world with no sun, no moon, no stars, just an endless, crushing, ink-black void. Now, imagine flipping a switch and turning on a pair of biological headlights that are attached to your own face. Let's dive into the bizarre world of deep-sea vision where the rules of light are completely rewritten. Down in the twilight and midnight zones, pressure is immense and sunlight is a distant memory. To survive here, you need more than just good vision. You need ocular superpowers. And nobody understood this better than the colossal squid. We're not just talking big eyes, we're talking about the largest eyes in the entire animal kingdom, period. Each one can be the size of a basketball. Think about that for a second. An eye as big as your head. But why? It's not for reading tiny print on a deep-sea menu. These massive, hypersensitive orbs are designed for one primary purpose: to spot the ghostly silhouette of its greatest predator, the sperm whale, moving against the faint bioluminescence far above. In the abyss, seeing isn't about clarity. It's about detecting the faintest disturbance in the darkness, and a bigger lens captures more of that precious, scarce light, giving the squid a few crucial seconds of warning. But spotting faint light is a passive game. Some creatures prefer to take a more active approach. Meet the stoplight loosejaw, a fish that looks like a monster from a fever dream. This incredible predator has a trick that is pure genius. Below its main eyes, it has a special bioluminescent organ that produces red light. Now here's the clever part. Most deep-sea creatures have evolved to see blue and green light, the most common wavelengths in the ocean. They physically cannot see red light. So, the loosejaw swims through the darkness with a secret biological sniper scope. It illuminates its unsuspecting prey with a beam of red light that the victim is completely blind to. The loosejaw can see the terrified shrimp or small fish perfectly, while the prey sees nothing but the same old blackness, right up until the moment it's devoured. It's the ultimate stealth technology, built right into its face. That's an amazing trick, but it's nothing compared to the sheer weirdness of the barrel-eye fish, also known as the spookfish. This creature takes weird eyes to a whole new level. First off, its head is completely transparent. You can literally see right through its forehead, and inside you can see its brain, nerves, and its eyes. And those eyes are not normal forward-facing spheres. They are massive, green, tubular barrels that are almost always pointing straight up. They act like twin telescopes, scanning the water column above for the faint shadows of prey. When it spots a tasty-looking morsel, the barrel eye can do something incredible. It can rotate its tubular eyes forward, tracking the prey as it moves in for the kill. It's like having a rotating gun turret inside a glass cockpit. As if that wasn't enough, some species of barrel eye have a second set of eyes that don't even use lenses. They use mirrors made from guanine crystals, like a biological reflecting telescope, to scan the area below them. They are literally looking up and down at the same time with completely different optical systems. Now, if you thought two different types of eyes on one fish was strange, let's talk about having two different kinds of eyes. The strawberry squid is a perfect example of hyperspecialization. This bizarre, beautiful creature has one small blue eye and one enormous, bulging, yellowish-green eye. It looks like a manufacturing defect, but it's a masterclass in efficiency. The squid typically swims at a tilted angle, with its giant yellow eye looking upwards. This eye is specifically tuned to detect the shadows of predators and prey against the faint, blue sunlight filtering down from the surface. The smaller blue eye, meanwhile, points downwards into the pitch-black abyss. Its job isn't to look for shadows, but to spot the flashes of bioluminescence from other creatures, either a potential meal or a potential mate. Two completely different jobs, two completely different tools for the job, all on one animal. I have to ask, if you could design your own mismatched pair of super eyes, what two abilities would you combine? Let me know in the comments below. This arms race for visual dominance leads to some incredible anatomical records. While the colossal squid has the largest eyes overall, the award for the largest eyes relative to body size goes to the vampire squid. This animal is not a true squid, and it's definitely not a vampire. It's a gentle scavenger, but its eyes are phenomenal. If a human had eyes with the same proportions, they would be the size of dinner plates. This huge eye-to-body ratio allows the vampire squid to be extraordinarily sensitive to any light at all. It doesn't hunt active prey. Instead, it uses its massive, sensitive eyes to see marine snow, the constant, slow drift of organic debris, mucus, and dead stuff falling from the upper ocean. To us, it would be like trying to spot individual specks of dust in a pitch-black warehouse, but to the vampire squid, it's a life-sustaining blizzard of food. So, we've seen creatures that can see invisible light and creatures with see-through heads. But what about a defense against these very tricks? The deep-sea dragonfish, another terrifying-looking predator, has evolved a potential countermeasure to the loose jaws red light trick. Scientists discovered that their eyes contain a chlorophyll-like derivative. They think this might sensitize their eyes to longer wavelengths, allowing them to see the red light that should be invisible. It's like they've stolen a piece of plant biology to develop their own set of night vision goggles that can detect the enemy's secret flashlight. It's a constant, silent war of visual technology being waged in the dark, with each new adaptation forcing another in response. Of course, it's not just fish that have adapted. Creeping along the seafloor, you might find a giant isopod. These oversized, armor-plated relatives of pillbugs can go for years without eating, but when they see something, they see it well. Their large, widely spaced compound eyes are packed with reflectors. A layer in the back of the eye, the tapetum lucidum, acts like a mirror. Any photon of light that enters the eye and misses a photoreceptor on the first pass is bounced back for a second chance. It's the same reason a cat's eyes seem to glow in the dark, but amplified for an environment where every single photon counts. This light-doubling system gives them an incredible ability to see in what we would consider absolute darkness. You'd think with all this focus on detecting faint light, color would be completely useless in the deep sea, and for the most part, you'd be right. Most deep-sea animals are colorblind, but there are exceptions, and they are baffling. Tiny crustaceans called ostracods perform some of the most complex bioluminescent mating displays on the planet, releasing intricate, pulsing patterns of light into the water to attract a partner. The sheer complexity of these light shows strongly suggests that the ostracods watching them can perceive differences in the light, perhaps even interpreting different flash patterns or colors as distinct signals. They've evolved a visual system that isn't for seeing the world around them, but for watching a very specific, very important light show put on by their own kind. In the abyss, vision isn't just about finding food or avoiding predators. It's about creating your own light in the darkness and finding another light that is looking for you. From basketball-sized whale detectors to biological sniper scopes, the eyes of the deep sea are a testament to the sheer, beautiful, and terrifying ingenuity of evolution. Imagine you're being hunted. A predator is stalking you from the shadows, and your life depends on spotting it first. For countless animals, this isn't a hypothetical. It's the daily reality that has shaped their vision into some of the most incredible survival tools on the planet. This is the story of how the hunted see the world. Let's start on a mountainside with an animal you've probably seen, but whose eyes you might have overlooked. Take a close look at a goat or even a sheep. You'll notice their pupils aren't round like ours. They're strange, horizontal rectangles. This isn't just a stylistic choice from nature. This rectangular shape gives them a stunning panoramic field of vision, stretching about 320 to 340 degrees around their body. For comparison, our vision covers about 185 degrees. This means a goat can see almost everything around it without even turning its head, which is a massive advantage when a wolf could be creeping up from any direction. But here's the truly mind-bending part. When a goat lowers its head to graze, its eyeballs actually rotate in their sockets by up to 50 degrees to keep those rectangular pupils perfectly parallel with the ground. Think about that. No matter the angle of its head, its view of the horizon remains stable and level. This allows it to keep a constant, crystal-clear lookout for predators approaching across the landscape, even while its face is buried in the grass. It's a built-in gyroscopic stabilizer for survival. From the mountainside to the meadow, another classic prey animal, the rabbit, has taken a different but equally effective approach. A rabbit's large eyes are placed high up and on the sides of its head. This placement is no accident. It grants the rabbit a field of vision that is nearly a full 360 degrees. It can see in front, to the sides, and almost directly behind itself simultaneously. This is the ultimate early warning system. The trade-off for this incredible peripheral vision is a tiny blind spot right in front of its own nose. That's right, a rabbit literally cannot see a carrot if it's directly under its mouth. It relies on its whiskers and sense of smell for that. This system is designed for one primary purpose: detecting motion from any angle and initiating a high-speed escape. Their vision is less about sharp, focused detail, like a predator needs, and more about being the ultimate motion detector. Anything that moves in that 360-degree bubble is a potential threat, triggering that famous zigzagging sprint to safety. Speaking of seeing in multiple directions, what if your eyes could move completely independently of one another, each one looking at a totally different scene? That's the daily reality for the chameleon. We often think of this as a hunting adaptation, and it is, but it's just as crucial for defense. A chameleon can swivel one eye to look forward, scanning for a tasty insect, while the other eye is pointed straight up or even backwards, watching the sky for a hungry hawk or the ground for a snake. Each eye has a rotational ability of about 180 degrees horizontally and 90 degrees vertically, giving it a combined non-overlapping field of view that is, once again, nearly 360 degrees. It's like having two independent, high-powered surveillance cameras mounted on your head. When it does spot a threat or prey, it can then snap both eyes forward to lock on with sharp, stereoscopic vision for precise depth perception. It's a masterful system that allows it to be both hunter and hunted, never letting its guard down for a single second. Now, let's leave the land behind because things get even stranger under the sea. Imagine an animal with not 2, not 10, but up to 200 eyes. Meet the scallop. This unassuming mollusk has a row of tiny, bright blue eyes lining the edge of its mantle, right where its 2 shells meet. They look like a beautiful, glittering necklace. But these aren't simple light-detecting spots. Each tiny eye is a surprisingly complex reflecting telescope in miniature. They each have a cornea, a lens, a retina, and even a curved mirror made of guanine crystals at the back. This mirror focuses incoming light onto 2 separate retinas, one that detects light and one that detects darkness. This setup is perfectly tuned to spot the approaching shadow of a predator, like a starfish or a hungry fish. The instant that shadow is detected by its network of eyes, it triggers a reflex. The scallop claps its shells together, shooting out a jet of water and propelling itself away in a comical, zigzagging escape. It's an entire visual security system built into the fringe of a seashell. What's the most bizarre-looking animal eye you've ever heard of? Drop your answer in the comments below. I'm curious to see what you come up with. Of course, for many prey animals, the most dangerous time isn't broad daylight. It's the twilight hours of dawn and dusk. This is where animals like deer have a critical advantage. Like many nocturnal creatures, they have a tapetum lucidum, that reflective layer behind the retina that causes their eyes to glow when hit by light. This layer acts like a mirror, bouncing photons back through the retina for a second chance at being absorbed, effectively amplifying low light. But the deer's adaptation goes deeper. Their photoreceptors are specifically tuned for the shorter wavelengths of light, the blues and ultraviolet light that dominate at sunrise and sunset. While their color vision is poor compared to ours, they see the world in shades of blue and yellow. Their sensitivity to this specific blue-shifted light is immense. This means that at the exact time when predators like wolves and cougars are most active, the forest isn't a dim, shadowy place to a deer. It's illuminated, with every moving shape standing out in stark contrast, giving them a crucial head start when a predator breaks cover. But what if a predator is hiding in plain sight, perfectly camouflaged against the seabed? For most animals, that predator is invisible, but not to a cuttlefish. Cuttlefish, often prey for dolphins, sharks, and seals, possess one of the most advanced visual superpowers in the animal kingdom. They can see polarized light. Light waves usually vibrate in all directions, but when light reflects off many surfaces, it becomes polarized, meaning it vibrates along a single plane. Humans are completely blind to this. A cuttlefish, however, can see it as clearly as we see color. This allows them to cut through the glare of light on water and, more importantly, to see things that are trying not to be seen. Many marine animals, like certain fish and crabs, have skin or shells that reflect polarized light differently from their surroundings. To a cuttlefish, a camouflaged flounder hiding on the sand might as well be glowing. This incredible ability to perceive a hidden dimension of light gives the cuttlefish a massive edge in detecting threats long before they become a danger. From the ocean floor, let's burst into the air with an animal that has to worry about threats from 2 different worlds at once. The flying fish is famous for its ability to glide over the water, but how does it manage to see where it's going while also watching for what's chasing it? It has solved this problem with a remarkable 2-in-1 eye. The fish's cornea is not a simple dome, it's shaped into a triangular or flattened dome. The bottom half is curved to see clearly underwater, helping it spot predators like tuna or mahi-mahi giving chase. But the top half of the same cornea is flattened. This flatter surface is perfectly adapted to see clearly through the air when the fish leaps out of the water. This means the moment it launches itself on a glide, it can instantly scan the sky for airborne threats, like frigate birds, without losing a moment to refocus. It has binocular vision for two separate environments, allowing it to navigate a high-speed, three-dimensional escape through both water and air, perfectly embodying the extraordinary lengths prey animals will go to just to see another day. Imagine being a tiny mouse scurrying through an open field. You think you're safe, but a mile above you, a single sharp eye has already picked you out from the landscape. For you, it's just another Tuesday. For the eagle, you are a pixel that has just resolved into perfect high-definition focus. This is the world of the predator, where vision isn't just about seeing, it's about targeting. Let's start with that eagle, the undisputed king of daytime aerial hunters. Its vision is legendary for a reason. An eagle can spot a rabbit from over 2 miles away, which is like you sitting on top of a 10-story building and being able to read the headlines on a newspaper lying on the sidewalk. But how? It's not just about magnification. Their eyes are packed with an incredible density of photoreceptor cells, about 5 times more than our own. And here's the really wild part. Eagles have 2 fovea, or centers of focus, in each eye. We only have 1. This allows them to have a sharp, clear, forward-facing view for binocular vision to judge distance perfectly, while simultaneously maintaining a crisp monocular view to the side. They are essentially seeing in both telephoto and wide-angle at the exact same time. This dual-focus system is what allows them to lock onto prey with pinpoint accuracy while soaring high above, never losing sight of their target as they begin their devastating dive. But staying locked on a target while you're moving at incredible speed is a whole different challenge. On the ground, the cheetah faces this exact problem. As the fastest land animal, sprinting at over 60 miles per hour, the world would just be a blur to us. But the cheetah's eyes are built for the chase. Instead of a round fovea like ours, they have a visual streak, a long horizontal line of nerve cells across their retina. This adaptation gives them a super sharp, panoramic view of the horizon, making it easy to scan for prey across the wide-open savanna. But the real trick is how they use it. During a full-speed pursuit, a cheetah can keep its head almost perfectly still, while its body contorts and twists beneath it. Their inner ear provides exceptional balance, and their eyes stay locked on the fleeing gazelle, compensating for every bounce and turn. It's the ultimate biological image stabilization, ensuring that even in the chaotic blur of the chase, the target remains crystal clear. Of course, not all predators are built for a straight-line sprint. Some are masters of aerial acrobatics, and their eyes have to keep up. Consider the dragonfly. Its massive compound eyes, which can take up almost its entire head, are marvels of engineering. Each eye is made up of to 30,000 individual lenses, or ommatidia, giving it a nearly 360-degree field of view. This means it can see forwards, sideways, and even partially behind itself, all at once. What's truly incredible is how its brain processes this information. A dragonfly doesn't just see where its prey is, it calculates where its prey is going. It intercepts its target with stunning precision by moving to a point in space where the fly will be in a fraction of a second. This is called interception pursuit, and it requires a level of predictive processing that is astonishing. It's less like a chase and more like a guided missile locking onto its heat signature. Have you ever tried to swat a dragonfly? Let me know in the comments how that worked out for you. From a high-speed chase, let's switch gears to the complete opposite, the art of the ambush. And for that, we have to talk about the chameleon. A chameleon's eyes are pure stealth technology. Each eye sits in a cone-shaped turret and can move completely independently of the other. One eye can be looking forward for a tasty cricket, while the other is scanning backwards for a hungry snake. It's like having 2 separate cameras on your head. This gives them a full 360-degree view without ever having to move their head, which is crucial for an animal that relies on staying perfectly still to avoid detection. But when it spots a potential meal, its strategy changes instantly. Both eyes swivel forward and lock onto the target, providing incredible binocular vision. And then comes the zoom. A chameleon's eyes have been found to have one of the highest magnification abilities in the animal kingdom, relative to their size. They can magnify an image with astonishing clarity, allowing them to judge the distance to their prey with the precision needed to unleash their famously fast and sticky tongue. Now, judging distance is one thing, but what if your prey is practically invisible? Let's dive underwater, where the mantis shrimp proves that seeing is about more than just clarity. We've talked about their insane color vision before, but for hunting, their ability to see polarized light is their true superpower. Light waves vibrate in different directions, and polarizing filters work by blocking all vibrations except for one direction. The mantis shrimp's eyes are exquisitely sensitive to this property of light. So what? Well, many marine animals, like fish and crustaceans, have scales or shells that reflect polarized light in a very specific way. To the mantis shrimp, these creatures practically glow against the background clutter of the reef. It allows them to cut through the shimmering reflections of sunlight on the water's surface and spot prey that would be camouflaged to our eyes. Some species can even see circularly polarized light, a ridiculously rare ability that scientists are still trying to fully understand. It's like they have a secret channel of visual information that only they can tune into, making them one of the most effective reef predators. You don't have to be big to have hyper-advanced hunter's eyes, though. Let's shrink down to the world of the jumping spider. These tiny arachnids don't build webs. They actively stalk and pounce on their prey like miniature cats. This requires phenomenal depth perception, and their eyes are built for it. They have 8 eyes arranged in 3 rows. The 2 large, forward-facing eyes are the stars of the show. They have a unique multi-layered retina. One layer receives green light in sharp focus, while another layer, slightly farther back, receives the same green light but slightly out of focus. The spider's tiny brain then compares the sharpness of the image on these 2 layers to calculate the exact distance to its target with incredible accuracy. It's a completely different method of judging distance than our binocular vision, and it's what allows them to make perfectly calculated leaps across vast distances, relative to their size, of course, to land squarely on their unsuspecting prey. Their other 6 eyes are used for peripheral vision and detecting motion, ensuring nothing sneaks up on them while they're lining up a jump. Finally, let's look at a predator that combines a view from 2 different worlds. The archerfish is a sharpshooter that hunts land-based insects from underwater. To do this, it has to solve a complex physics problem every single time it wants to eat. When you look into water, objects appear to be in a different place than they really are due to the refraction, or bending, of light as it passes from air to water. The archerfish has to account for this. Its eyes are positioned to give it excellent binocular vision looking up towards the surface. When it spots a bug on an overhanging leaf, it calculates the bug's actual location, not its apparent one. Then it shoots a highly pressurized jet of water from its mouth, knocking the insect into the water. Younger archerfish are less accurate and learn through practice, but experienced adults can hit a target from several feet away with stunning regularity. Their eyes don't just see, they do trigonometry, turning a complex optical illusion into a reliable way to get their next meal. Imagine having a pair of binoculars permanently attached to your face, but they're 1,000 times better and can see colors you can't even comprehend. Today, we're zooming in on the undisputed champions of long-distance sight. Let's start with the animal you probably expected, the one whose name is literally synonymous with sharp vision, the eagle. But the reality is so much cooler than you think. An eagle's vision is estimated to be 4 to 8 times stronger than that of the average human. A martial eagle, for instance, can spot a rabbit from over 3 miles away. To put that in perspective, if you were standing on top of a 10-story building, you could read the headlines on a newspaper lying on the ground. But here's where it gets truly wild. The secret isn't just a powerful lens, it's in the software and the hardware. Our eyes have one fovea, a small depression in the retina packed with cone cells that gives us our sharp central vision. Eagles have 2. They have the central fovea we do, for crisp, monocular vision, but they also have a second temporal fovea. When they lock both eyes onto a target, images from both temporal fovea overlap, creating a breathtakingly precise telephoto view, a binocular vision that grants them impeccable depth perception. It's like having a standard view and a zoom lens operating simultaneously. And the resolution of that zoom is just staggering. The density of photoreceptors in an eagle's fovea is off the charts. We humans have about 200,000 cones per square millimeter in our fovea. A bald eagle? They have over 1 million. That's 5 times the detail packed into the same amount of space. This creates an image so incredibly sharp and rich with information that it's almost impossible for us to imagine. It's the difference between watching a standard definition video and being plugged directly into an 8K Ultra HD reality. On top of all that, they have a built-in cleaning and protection system that would make any engineer jealous. It's called a nictitating membrane, a translucent third eyelid that sweeps horizontally across the eyeball. It moistens and cleans the eye without the eagle ever having to blink, meaning they never ever have to take their eyes off their prey, even for a split second. If you could have one eagle eye power, would you choose the biological zoom lens or the self-cleaning third eyelid? Let me know your pick in the comments. From one master of the sky to another, let's climb to an altitude where humans can't even breathe. High above the Earth, soaring in the jet stream, the Ruppel's griffon vulture holds the record for the highest flying bird, reaching astonishing heights of 37,000 feet. That's the cruising altitude of a commercial airliner. From that vantage point, the world below is a distant map. Yet these birds can spot a carcass just a few feet across on the ground. Their eyes are enormous, packed with cone cells to give them supreme color vision and acuity during the day. This allows them to scan vast swaths of the Serengeti for any sign of a meal. They are nature's ultimate surveillance drones, operating in thin air and spotting opportunities from a height that would render the world a blurry, abstract painting to our own eyes. But the evolutionary arms race isn't just about the hunters. The hunted have developed their own incredible visual defenses. Out on the open prairies of North America lives the pronghorn, an animal that looks like a deer but is more closely related to goats and, weirdly, giraffes. The pronghorn's defense strategy is simple. See trouble coming from a very, very long way away, and then run very, very fast. To achieve this, it has developed some of the most remarkable eyes in the animal kingdom. A pronghorn's eyes are massive, about 1.5 inches in diameter, almost as large as an elephant's eyes, all packed into a much smaller head. They are set far out on the sides of the skull, granting them a staggering near panoramic field of view of about 320 degrees. This means they can see almost everything around them, including directly behind, without ever turning their head. They are constantly scanning for the slightest hint of a predator, like a wolf or a coyote, and they can detect movement up to 4 miles away. So not only do they have an almost complete panoramic view, but that entire view is in long-range telescopic focus. It's like living inside a watchtower with high-powered binoculars pointed in every single direction at once. While they don't have the razor-sharp focus of an eagle on a single point, their ability to detect the flicker of movement across a vast landscape is second to none, giving them the crucial head start they need to survive. What animal do you think has the weirdest survival adaptation? Drop your thoughts below. Speaking of massive eyes, if you think the pronghorns are impressive for its body size, let's talk about the undisputed land-based champion of ocular real estate, the ostrich. The ostrich holds the title for the largest eye of any land animal on Earth. Each one is about 2 inches across, roughly the size of a billiard ball. And here's the fact that always gets me. An ostrich's eye is literally bigger than its brain. Let that sink in for a moment. Evolution took a look at the ostrich and decided that seeing really, really far away was more important than complex problem solving. And it worked. These gigantic eyes act like powerful telephoto lenses, allowing them to spot lions or hyenas from over 2 miles away across the flat, open savanna. This gives them, and the other animals they graze with, like zebras and wildebeest, a vital early warning system. It's a classic case of nature prioritizing a specific tool to an almost comical degree. This is a fun one. Bigger eyes or a bigger brain? Which would you choose and why? Comment your answer. Now let's bring it back from the prey to a predator, but one whose vision is built for something truly extraordinary: speed. The peregrine falcon is the fastest animal on the planet. During its hunting dive, or stoop, it can reach speeds of over 200 miles per hour. At that velocity, the world would become an incomprehensible, streaking blur to us. But the peregrine sees everything in glorious slow motion. The key is something called the flicker fusion frequency, which is basically the speed at which the eye and brain can process distinct images. Humans have a flicker fusion rate of about 60 Hz, or 60 frames per second. For a peregrine falcon, it's an incredible 129 Hz. They are processing visual information more than twice as fast as we are. This allows them to track the erratic movements of a pigeon or a duck mid-flight, make micro-adjustments to their trajectory at 200 miles per hour, and strike with pinpoint accuracy. Their world doesn't blur, it just flows with more information per second, giving them the ultimate high-speed processing power to match their high-speed bodies. What's the most impressive feat of speed you've ever witnessed in nature? I'd love to read your stories. These long-distance legends show us that seeing isn't just about looking, but about surviving, hunting, and mastering the world from miles away. Imagine your eye wasn't just for seeing. What if, the moment you spotted a tasty snack, your eyeball itself could reach out and snatch it? We're diving deep into the world of the smallest creatures. It's just another day at the office. We're diving deep into the world of the unseen, exploring the tiny titans with vision that defies belief. Let's start with a creature that absolutely should not exist. Deep in the sunlit layers of the ocean drifts a single-celled organism called the Warnawid dinoflagellate. Now, being single-celled means you are the absolute definition of minimalist life. You're a microscopic bag of goo with a purpose. Yet, this particular bag of goo decided to build one of the most complex structures known in any single-celled life form: an eye. Scientists call it an ocelloid, and it's so ridiculously advanced it looks like it was stolen from a much larger animal. It has a component that functions like a cornea and another that works as a lens, focusing light onto a retina-like base. This retina is made from a network of plastids, which are organelles usually involved in photosynthesis. So, this creature essentially repurposed its internal solar panels to create a light-gathering, image-forming eye. It's the biological equivalent of taking apart a toaster and building a fully functional camera. And remember, this entire intricate system, complete with a focusing lens and a light-sensitive back wall, is packed inside a creature smaller than a grain of salt. It's an eye more complex than what you'd find in some species of squid or fish, all inside one cell. But here's the kicker. We're still not entirely sure what it's using this unbelievable eye for. The leading theory is that it hunts other single-celled organisms, specifically other dinoflagellates. Its prey is often transparent, making them nearly impossible to spot. However, their cellular structures, like their chromosomes, can polarize light in a specific way. It's thought the Warnowitz hyper-advanced oceloi isn't just seeing light, but seeing these hidden signatures of polarization, allowing it to spot invisible prey in a crowded microscopic world. It's a ghost hunting other ghosts using a biological camera that shouldn't even be possible. From a single cell with a camera to one of the most numerous animals on Earth, let's talk about the copepod. If you were to scoop a bucket of seawater, you'd likely have thousands of these tiny crustaceans without even knowing it. They are the bugs of the sea, and they are a primary food source for, well, almost everything. And to navigate their world, most adult copepods sport a single, central eye right in the middle of their head, making them look like tiny, underwater cyclops. This isn't a simple light or dark detector either. This median eye, known as a Doppler eye, is surprisingly sophisticated for its size. In many species, it's composed of 3 cups, or ocelli, arranged to give it a surprisingly wide field of view. One cup might look up, while 2 others look to the sides, allowing the copod to sense the direction of light, detect the shadow of an approaching predator, and navigate through the water column. It's a simple, low-energy solution for 3D awareness, but nature loves to upgrade. Some species of copepod, not content with their cyclops eye, evolved to have more. The family Pontelidae, for example, features copepods with not 1, but up to 3 eyes. They keep the central Doppler eye, but add 2 large, paired lens eyes on the side of their head. What's truly wild is how these lenses work. They can actually move and focus, scanning their environment like tiny biological radar dishes. These lenses project an image onto a light-sensitive receptor deep inside their body, giving them true image-forming vision. One particular species, Labidocera aestiva, has a dorsal eye that points upwards to watch for predators from above, and a separate forward-pointing eye. This gives it a panoramic, almost bifocal view of its world, a critical advantage when you're on everyone's menu. If you had to design the perfect alarm system for a creature this small, you'd be hard-pressed to come up with something better. It makes you wonder, if you could have an extra eye, where would you put it for the most advantage? Let me know your design in the comments. Now, let's scale up just a bit from the microscopic to the merely small and talk about an animal with an eye-watering number of eyes, the box jellyfish. These ghostly drifters are famous for their potent venom, but their visual system is arguably just as shocking. They don't have 2 eyes or even 8 like a spider. A box jellyfish has 24 eyes, organized into 4 sensory clubs called rhopalia that dangle from the edge of its bell. And these aren't just 24 copies of the same eye. They are different types of eyes, each with a specialized job. There are simple pit eyes that just detect light levels. There are slit eyes that do something similar. But then there are the lens eyes. Each rhopalium has 2 sophisticated lens eyes, an upper and a lower one. The upper lens eye is pointed perpetually upwards, towards the water's surface. It's believed this eye is used for navigation, allowing the jellyfish to stay near the surface and its food source in coastal mangrove swamps without accidentally beaching itself. It's essentially a biological sextant, guiding the animal by the light from above. The lower lens eye, however, is a true image-forming eye. It has a cornea, a lens, and a retina capable of seeing blurry shapes and forms. It points down and out, scanning for obstacles like mangrove roots or potential prey. This means a single-box jellyfish is simultaneously looking up to navigate and looking down to hunt and avoid crashing. And here is the part that breaks your brain. It does all of this without a brain. There is no central processing unit. The information from these 24 eyes is processed right there in the rhopalia. Each of the 4 sensory clubs acts like its own mini brain, coordinating the pulsing of the bell to steer the jellyfish. It's a decentralized visual system that allows a creature with no head to perform complex, visually guided behaviors. It's seeing, steering, and hunting on autopilot. Speaking of seeing things that are otherwise hidden, that brings us to a fan favorite, the undisputed king of complex vision, the mantis shrimp. While not microscopic itself, its eyes are built to perceive the world on a level of detail that is, for us, microscopic. Each of their eyes is mounted on a stalk and can move independently. You know how you need to turn your head to look around? They don't. Each eye can swivel, track, and focus on its own. This would be impressive enough, but that's barely scratching the surface. Each of their compound eyes is split into 3 distinct sections, creating what's known as trinocular vision in a single eye. This means each eye has its own built-in depth perception. A mantis shrimp can judge distance with one eye closed. Think about that. You need 2 eyes to see in 3D. It only needs 1. It has a spare. I'd love to know what you think the biggest advantage of having built-in depth perception in each eye would be. Tell me your ideas in the comments. But the real magic is in what these eyes can see, not just how they see it. Humans have 3 types of color-receptive cones in our eyes, for red, green, and blue. All the colors you've ever seen are just a mix of these 3. A mantis stripe has 16. We can't even begin to imagine what those extra 13 color channels would look like. It sees a rainbow of colors that are literally inconceivable to the human mind. Furthermore, it's a master of seeing polarized light. Light waves usually vibrate in all directions, but when light reflects off a surface, it often becomes organized or polarized. The mantis shrimp can see this polarization, including a rare type called circular polarization, which no other animal is known to see. For the mantis shrimp, this is a secret code. The shiny shell of a potential prey item or the shimmering scales of a rival might reflect polarized light in a very specific way, making them pop out from the background like a neon sign. It's like having a superpower that lets you see things that are trying their best to be invisible. For them, the world is painted with an extra layer of information, a hidden channel of reality that we are completely blind to. What do you think the world would look like if we could suddenly see all the colors a mantis shrimp sees? Drop your trippiest description in the comments below. This ability to see hidden patterns is a recurring theme in the world of super eyes. It's not always about seeing farther or with more clarity in the way we think of it. For many of these tiny titans, vision is about decoding the unseen. Think about the Portia jumping spider. It has 8 eyes, with the 2 large forward-facing principal eyes granting it vision almost as acute as a cat's, which is absurd for an animal that small. They use this incredible sight to hunt other spiders, their favorite prey. They can spot another spider from incredible distances and then plan a route to ambush it, sometimes taking hours to circumnavigate a branch to get the perfect angle of attack. This requires not just seeing, but understanding a 3-dimensional space and planning for the future. Researchers have even observed them using trial and error to solve problems, a sign of genuine intelligence. What's the most surprisingly clever thing you've ever seen a small animal or insect do? Share your story in the comments. I'm genuinely curious. From a single cell that built a camera, to a jellyfish that sees without a brain, to a shrimp that sees colors we can't name, the microscopic world is home to visual systems that are as alien as they are ingenious. These tiny titans prove that when it comes to vision, size truly doesn't matter. It's all about how you see the world that's right in front of you, and sometimes the world that's hidden from everyone else. All right, we've seen eyes that act like compasses and eyes that can see polarized light, but what about the ultimate superpower? What happens when an eye is damaged beyond repair? For us, it's a permanent problem. But in the animal kingdom, losing an eye, or even just part of it, isn't always the end of the story. It's just the beginning of one of nature's most incredible magic tricks, regeneration. Imagine a salamander. If its eye lens is surgically removed, completely gone, it doesn't panic. It just grows a new one. This isn't just healing a cut, it's rebuilding a complex, transparent, perfectly focused biological camera lens from scratch. And get this, it does it in about 30 days. The process is a marvel of cellular alchemy. Cells in the upper part of its iris, the colored part of the eye, get a chemical signal that says, hey, the lens is missing. These pigmented iris cells then do something that sounds like science fiction. They de-differentiate. They basically forget they were ever iris cells, revert to a stem cell-like state, and then start dividing and transforming into brand new, perfectly clear lens cells. It's like a brick in a wall deciding to turn back into clay and then remolding itself into a window. The salamander can repeat this trick over and over again throughout its life, with the new lens being functionally identical to the one it lost. It isn't a lesser copy, it's a perfect replacement. But how deep does this ability go? It's not just the lens. Newts, which are a type of salamander, can regenerate their retinas as well. The retina is the light-sensing tissue at the back of the eye, the part that's like the film in a camera. If the retina is damaged or even removed, the newt can regrow it. Similar to the lens, specialized cells, in this case retinal pigment epithelial cells, kick into gear. They start dividing and rebuilding the entire intricate network of photoreceptors, the rods and cones, and all the neurons needed to process visual information. What's truly staggering is that after regrowing this incredibly complex neural tissue, the newt also regenerates the severed optic nerve, reconnecting its brand new retina to its brain. And the connections it makes are correct. The animal's vision is fully restored. It doesn't just patch the hole, it rebuilds the entire system and plugs it back in, good as new. As incredible as that is, there's another creature that puts even the salamander to shame in the eye repair department, the humble zebrafish. You might know them from home aquariums, but these little fish are regeneration superstars. Their eyes are under constant assault from light, which can damage and kill their photoreceptor cells. Instead of letting this damage accumulate, the zebrafish has a system of continuous self-repair. It's not just healing after a major injury, it's performing constant maintenance. The key players here are a type of cell called Mueller glia. In our eyes, Mueller glia are just support cells, the structural crew that keeps everything in place. But in a zebrafish, if a photoreceptor dies, a nearby Mueller glia cell senses it. It then divides, and one of its daughter cells transforms into a brand new, fully functional photoreceptor to replace the one that was lost. The fish essentially has a team of live-in repair technicians for its eyes, constantly patching up damage so its vision remains perfect its entire life. This raises a fascinating and slightly frustrating point for us. We humans have Mueller glia cells in our own retinas. They're right there. The genetic toolkit for regeneration might be dormant within our own eyes, but for some reason, in mammals, that switch is turned off. For the zebrafish, it's always on. Scientists are studying these fish intensely, hoping that one day they might learn how to flip that switch in our own cells, potentially curing forms of blindness that are currently untreatable. If you could have one animal's regenerative ability, what would it be? The salamander's limb regrowth or the zebrafish's eye repair? Let me know your superpower of choice in the comments. Now, you might think this is an amphibian and fish thing only, but some reptiles are in on the action too. The leopard gecko, for instance, has shown a remarkable ability to regenerate neurons within its retina following injury. While not as dramatic as regrowing an entire eye, it's still a feat far beyond our own capabilities. They can replace damaged ganglion cells and other retinal neurons, which is a critical step in restoring the pathway of information from the eye to the brain. This suggests that the ancient blueprint for eye regeneration hasn't been completely lost in land-dwelling vertebrates. It's just become far more limited. It's like they have a few pages from the instruction manual, while the salamander has the entire library. But let's venture outside the world of vertebrates for a moment, because what about creatures like spiders? They rely so heavily on their multiple eyes. Can they fix them? The answer is a bit of a yes and no, which makes it even more interesting. For most spiders, their two large primary eyes, the ones that give them their sharpest vision, cannot be regenerated if they are lost or seriously damaged. That's it, they're gone for good. However, many spiders also have a set of smaller, secondary eyes, which are more primitive and often used for detecting motion or changes in light. If one of these secondary eyes is damaged, especially during a molt, some spider species can partially or even fully regenerate it in the next molt. The new eye might not be perfect. It might be smaller or less functional, but it's still an incredible feat of rebuilding a sensory organ. It's a strange trade-off. Their high-definition main cameras are irreplaceable, but their low-resolution motion sensors can be patched up or swapped out. Okay, let's bring it back to the undisputed champion, the heavyweight title holder of regeneration. We've talked about rebuilding a lens, a retina, an optic nerve, but what about all of it at once and more? For that, we turn to the axolotl, the Mexican walking fish that's technically a species of salamander. The axolotl is famous for its ability to regrow limbs, jaws, and even its spinal cord. But its ocular abilities are on another level. An axolotl can regenerate its entire eye. But the truly mind-bending part is that it can regenerate portions of its brain as well. Scientists have conducted experiments where they removed an axolotl's eye and a piece of its brain, and the animal simply grew both back. It doesn't just regenerate the hardware, it regenerates the processor it plugs into. And after this astonishing act of reconstruction, its vision is restored. This isn't just healing, it's a complete biological reboot, demonstrating a mastery over its own body that is, for us, almost impossible to comprehend. It's a living, breathing example that for some animals, even the most delicate and complex organs are not just replaceable parts, but renewable resources. Imagine stepping outside and seeing not just colors and shapes, but invisible patterns painted across the entire sky, secret roadmaps written in light itself. Well, for many animals, this isn't science fiction, it's just another Tuesday. We're now diving into the world of polarized light, a hidden dimension of vision that turns the ordinary into the extraordinary. Let's start with a true master of disguise, the cuttlefish. We've talked about their incredible color-changing skin, but that's only half the story. Their strangely shaped W pupils give them an exceptionally wide field of view, but their real superpower is in seeing polarized light. Think of light waves vibrating in all directions. A polarizing filter, like in your sunglasses, blocks all waves except those vibrating in one specific plane. Cuttlefish can see this plane of vibration. Why is this useful? Well, many fish have scales that reflect polarized light differently than the background water, making them stick out like a sore thumb to a cuttlefish, even if they're perfectly camouflaged in normal light. It's like having a special filter that instantly reveals hidden enemies or an unsuspecting lunch. But here is where it gets truly mind-bending. The cuttlefish doesn't just see polarized light, it creates it. Its skin contains layers of light-reflecting cells called iridophores, which it can actively control to polarize the light bouncing off its body. This means it can send secret messages to other cuttlefish using patterns of polarized light that are completely invisible to most other predators. It's a clandestine communication channel, a visual whisper that allows them to signal aggression, intent, or attraction without tipping off anyone else in the neighborhood. From the ocean's masters of disguise, let's move to the tireless workers of the sky, bees. A bee might seem like a simple creature, but its navigational system is more sophisticated than you might think. We know they do their famous waggle dance to tell their hive mates the direction and distance to a flower patch. But how does the scout bee know where it's going in the first place? It uses the sun as a compass. But what happens on a cloudy day? This is where their superpower kicks in. Bee eyes are equipped with special photoreceptors in the dorsal, or upper, region of their eye that are exquisitely sensitive to the polarization of light. Sunlight scatters as it passes through the atmosphere, creating a predictable pattern of polarized light across the entire sky, centered around the sun. Even if the sun itself is completely obscured by clouds, a bee can see a small patch of this pattern and instantly deduce the sun's position. It's like having a celestial GPS built right into its head. This allows them to forage for miles and return to the hive with pinpoint accuracy, regardless of the weather. They are navigating by an invisible celestial map that is always there, waiting to be read. Speaking of built-in GPS, let's talk about an ant that performs truly epic feats of navigation. The Saharan desert ant, Cataglyphus fortis, lives in one of the most featureless environments on Earth, a scorching sea of sand with almost no landmarks. To find food, it will wander in seemingly random, zigzagging patterns for hundreds of feet away from its tiny, hidden nest entrance. Yet, when it finds a scrap of food, it turns and makes a dead straight beeline right back home. How? It's not using scent trails, which would evaporate instantly in the desert heat. Instead, it combines two incredible abilities. It counts its steps to measure distance, and it uses the polarization pattern of the sky as a compass, just like the bee. Its compound eyes have specialized photoreceptors that detect the orientation of polarized light, allowing it to maintain a constant bearing relative to the sun's position. It continuously updates its internal map, so at any given moment, it knows the precise direction and distance back to its starting point. It's a living, breathing example of vector calculus, navigating a barren wasteland with an accuracy that would make early explorers deeply envious. Of course, no discussion of polarized light vision would be complete without mentioning the undisputed champion, the heavyweight king of complex eyes, the mantis shrimp. Their vision is so far beyond ours, it's almost impossible to comprehend. Not only can they see polarized light, but they can see both linear and circular polarized light, a property of light that spirals like a corkscrew as it travels. To put that in perspective, we can't see any polarization without tools, and almost no other animal is known to see circular polarization at all. They are unique. Each of their eyes contains 6 polarization-sensitive cells, compared to the one type we have for seeing dim light. Scientists believe this gives them a massive advantage in their vibrant coral reef homes. The shells and carapaces of many crustaceans, a favorite food source, reflect circularly polarized light in a way that other objects don't. So, while a crab might look perfectly camouflaged to another fish, to a mantis shrimp, it might as well be glowing with a neon sign that says, "Eat me." What is the most bizarre animal ability you've ever heard of? Drop it in the comments below. I'm curious to see what you all come up with. This incredible vision may also be used for secret communication, allowing them to signal to mates or rivals with flashy polarized patterns on their bodies that are invisible to the predators hunting them. From the brightly lit reefs, we go back to the hunters of the open ocean. The octopus, a close relative of the cuttlefish, also possesses this remarkable ability. While their brain doesn't process color in the same way ours does, their ability to see polarized light more than makes up for it. This skill is a game changer for hunting. Imagine trying to spot a nearly transparent fish shimmering against the shimmering surface of the water. It's an almost impossible task for a human eye, but for an octopus, it's easy. The skin of many fish reflects polarized light, so against the differently polarized background of the water, that nearly invisible fish suddenly pops into high contrast. The octopus essentially sees the outline of its prey glowing, turning a difficult game of hide and seek into a simple target practice. This allows them to be incredibly efficient predators, detecting camouflaged or silvery prey that other animals would swim right past without a second glance. It's a visual advantage that helps make them one of the ocean's most formidable hunters. But this incredible sense isn't just for finding food or a mate. For some, it's about making a clean getaway with their hard-earned prize. Believe it or not, the humble dung beetle is a surprisingly skilled navigator. After a dung beetle fashions a fresh ball of dung, its top priority is to roll it away in the straightest line possible. Any deviation or circling back risks having the ball stolen by other beetles. On a clear night, they use the faint light of the Milky Way as a celestial guide. But what about on a moonlit night, when the moon's brightness washes out the stars? They switch to Plan B. The African dung beetle, Scarabaeus satyrus, uses the polarized light of the moon. Moonlight, just like sunlight, polarizes as it scatters through the atmosphere, creating a faint but detectable pattern across the night sky. The beetle's eyes are sensitive enough to pick up on this pattern, allowing them to lock onto a bearing and roll their precious dung ball away in a perfectly straight line, ensuring they don't accidentally circle back to the chaotic scrum around the dung pile. Finally, this super sense can be the ultimate defense. For small fish like anchovies and sardines, the open ocean is a terrifyingly dangerous place, filled with transparent predators like jellyfish. How do you avoid something you can't see? You guessed it, polarized light. The bodies of many gelatinous creatures, while transparent, are made of tissues that are birefringent. This is a fancy way of saying they change the polarization of light that passes through them. So, for an anchovy scanning the water, the background ocean has one uniform polarization pattern. But when a jellyfish drifts by, the light passing through its body becomes slightly altered, creating a distortion in that pattern. This subtle change, completely invisible to us, acts as an early warning system, revealing the presence of a nearly invisible predator before it's too late. It's a life-saving visual trick that gives these tiny fish a fighting chance in the vast, dangerous blue. Imagine seeing a lightning bolt not as a flash, but as a slow, crackling river of light crawling across the sky. For some animals, our world is permanently stuck in ultra-slow motion. Let's explore the super-speed vision that makes our own eyes look like they're buffering. We've seen eyes that act like compasses and eyes that can see the invisible, but what about eyes that are simply faster? So much faster that they perceive reality on a completely different timeline than we do. The undisputed champion, the heavyweight title holder of high-speed vision, is the dragonfly. Its two massive compound eyes are so large they meet at the top of its head, essentially giving it a panoramic, nearly 360-degree view of the world. But the size is just the start. Each of those giant eyes is composed of up to 30,000 individual lenses, or ommatidia. 30,000! Each one acts like a single pixel, feeding a tiny piece of the puzzle to the dragonfly's brain. This structure is what allows it to process images at a blistering rate of over 300 frames per second. For comparison, a high-end movie is usually projected at 24 or maybe 60 frames per second. To a dragonfly, watching a film would be like looking at a slideshow where the slides change once every few seconds. This incredible processing speed isn't just for show. It gives the dragonfly a terrifying advantage as a predator. While we react to where something is, a dragonfly's brain, fueled by this fire hose of visual data, can accurately predict where its prey will be. It runs complex interception calculations in mid-air, allowing it to snatch other insects with a success rate of over 95%. It's not just reacting, it's seeing the future, a fraction of a second at a time. This makes it one of the most efficient hunters on the entire planet, all thanks to eyes that are living, breathing supercomputers. But what happens when you're not snatching a gnat out of the air, but plummeting towards the ground at over 200 miles per hour? For that, we turn to the peregrine falcon, the fastest animal on Earth. Its vision has to be more than fast. It has to be impossibly sharp and stable under extreme G-forces. A falcon's eyes have two fovea, which are areas on the retina with a super high concentration of photoreceptor cells. We humans have just one. The falcon uses its central fovea for incredible long-distance monocular vision, like a built-in telescope to spot a pigeon from over a mile away. But when it dives, it switches to its second or temporal fovea. This one provides stunningly sharp binocular vision, giving it the depth perception needed to calculate the final, lethal strike on its target. And to keep that vision clear during its high-speed stoop, the peregrine falcon has a secret weapon, a third eyelid. It's called a nictating membrane, and it sweeps across the eye from the side. It's translucent, so the falcon can still see through it, but it functions like a pair of built-in goggles. It clears debris, keeps the eyeball moist against the rushing wind, and protects it from the impact of hitting its prey, all without causing the bird to blink and lose sight of its target for even a millisecond. It's a breathtakingly elegant solution to a very high-speed problem. It's just incredible how an animal's body adapts so perfectly to its environment and skills. It makes you wonder, if you could have one animal superpower, what would it be? Let me know your pick down in the comments. Now, you might think dragonflies and falcons have the market cornered on fast vision, but some of the most impressive optical engineering belongs to a much more common insect, the hoverfly. You've seen them darting around flowers looking like tiny bees. Their flight is a masterpiece of chaos. They can hover, fly backwards, and make instantaneous right-angle turns. To do this without crashing requires visual processing that is, in some respects, even more specialized than a dragonfly's. Their brain has to update their flight path based on visual information in as little as 30 milliseconds. That's faster than a single frame of a movie. And male hoverflies take this a step further. They have a specialized region in the upper part of their compound eyes known as the love spot. This area has larger facets and is acutely sensitive to the subtle movements and flickering wing beats of female hoverflies. It allows a male to lock on to a potential mate from a distance and execute a perfect high-speed aerial pursuit, tracking her every zig and zag with unparalleled precision. It's a dedicated visual processor just for finding a date. But seeing fast isn't always about pursuit. Sometimes it's about pure ambush. Meet the robber fly, an insect that looks like it was designed in a secret lab for aerial combat. Its eyes are fine-tuned for one thing: motion detection. They have a very high flicker fusion rate, which is the speed at which a series of images is perceived as continuous motion. Their rate is so high that the frantic buzzing of a bee's wings appears to them as a series of distinct individual flaps. This allows them to see an approaching insect not as a blur, but as a clear target. Their reaction time is so infinitesimally small that they can launch from a standstill, intercept another fast-moving insect mid-flight, and be back on their perch before the victim even knows what happened. To a robber fly, our frantic hand-waving to shoo them away might as well be the slow, lazy drifting of a continent. Finally, we have one of the most wonderfully bizarre examples of speed creating its own unique problem. The tiger beetle is the fastest-running insect in the world, capable of covering 125 times its own body length in a single second. If a human could do that, they'd be running at over 480 miles per hour. But its speed creates a paradox. The beetle moves so fast that its eyes literally cannot gather photons fast enough for its brain to form a coherent image of the world. In other words, when it runs at top speed, the tiger beetle goes temporarily blind. It is effectively outrunning its own vision. This is why you see them running in short, sharp bursts. They sprint, stop dead, let their visual system catch up and reacquire the target, and then sprint again. It's an endless cycle of run blind, stop, see, repeat. It's a fascinating reminder that even in the world of super eyes, there are physical limits. And sometimes being the fastest means you have to learn to hit the pause button just to see where you're going. Imagine for a moment that your vision wasn't one single smooth picture. Instead, imagine seeing the world through 1,000 tiny television screens, all packed together, each one showing you a slightly different angle of reality. That's the secret, multifaceted world of the compound eye. We've journeyed through the realms of eagles and chameleons, but now we're diving into a visual system that belongs more to science fiction than to our own experience. So, how does it actually work? Well, it's not one eye, but a collection of up to thousands of individual optical units called ommatidia. Think of them as long, thin tubes, each with its own lens and light-detecting cells. And they come in two main designs. The first is the apposition eye, common in daytime insects like bees and dragonflies. Here, each ommatidium is like a pixel, gathering light from one specific point and contributing its tiny piece to a larger mosaic image. It's fantastic for detail and seeing in bright light. But for creatures of the night, like moths and crayfish, evolution cooked up the superposition eye. This design is a low-light masterpiece. Light from multiple lenses is funneled and focused onto a single photoreceptor, creating a much brighter, more sensitive image, sacrificing a bit of sharpness for the ability to see in near total darkness. It's the difference between a high-definition photo and a grainy but visible night vision shot. Speaking of masterpieces, let's talk about the dragonfly. Its eyes are so massive they cover almost its entire head, looking like a fighter pilot's helmet. And for good reason. Each of these giant orbs can contain up to 30,000 of those ommatidia, giving it an almost 360-degree field of view. It can literally see in every direction except for one tiny blind spot directly behind it. But the real superpower isn't just the panoramic view. While we see the world with 3 types of color-receptive cones, for red, green, and blue, dragonflies possess up to 30 different types of opsins, the proteins that detect light. This means they see a universe of colors we can't even begin to imagine, including ultraviolet light. This UV vision is their secret weapon for hunting, as it makes the reflective wings of their prey shimmer and stand out against the backdrop of the sky. Combine that with a brain that processes images at over 200 frames per second, more than triple our rate, and you have a predator that perceives our world in glorious slow motion. able to calculate the trajectory of a fly and snatch it from the air with terrifying precision. If you could have one dragonfly vision superpower, seeing the world in slow motion, or seeing a whole new spectrum of UV colors, which would you choose? Let me know your pick down below. Now, if the dragonfly is a high-performance fighter jet, the mantis shrimp is a psychedelic, hyper-advanced alien warship. We've touched on them before, but their compound eyes are so bizarre they deserve a second look. For years, scientists were baffled. With 12 types of photoreceptors for color, compared to our measly 3, they assumed the mantis shrimp must see a rainbow of unimaginable complexity. But the truth is somehow even stranger. Recent studies suggest their brains don't actually blend these channels to see more colors. Instead, each of the 12 channels is tuned to a very specific wavelength of light, acting like a set of pre-programmed color scanners. When light of that exact color hits the receptor, it sends a simple, direct signal to the brain. There's no complex processing, it's just an instant recognition system. This frees up precious brain power for what mantis shrimp do best, calculating the physics of their ridiculously fast and powerful punches. It's a vision system built for speed and efficiency, not for admiring a sunset. And as if that weren't enough, they can see 6 different types of polarized light, a property of light waves we are completely blind to. They use these secret channels for communication, flashing polarized patterns at each other that are completely invisible to any predator or prey. But complex compound eyes aren't a recent invention. Let's rewind the clock way back. About 250 million years ago, long before the dinosaurs, trilobites ruled the ancient seas. And their fossils reveal something astonishing. Some of the most sophisticated eyes ever to evolve. Unlike the soft, organic lenses of modern insects, trilobite lenses were made of solid, inorganic calcite crystals, the same mineral that forms limestone and marble. They literally had eyes made of rock. Even more incredibly, a group of trilobites developed what are called schizochral eyes. These weren't just a mosaic of simple lenses. Each lens was larger, optically isolated from its neighbors, and was a complex doublet structure. This unique design perfectly corrected for spherical aberration, the optical distortion that causes blurry images. It's a problem that plagued human lens makers until physicists like Descartes and Huygens figured out the mathematics in the 17th century. These ancient arthropods had solved it millions of years earlier, evolving what was essentially a set of perfectly crafted crystal bifocals. It's just mind-blowing to think about evolution creating perfect corrective lenses out of crystal. What's the most amazing extinct animal you've ever heard of? Share it in the comments. From the ancient past to the buzzing present, the honeybee's eye is a master of navigation and discovery. To us, a field of flowers is a beautiful wash of color. To a bee, it's a landscape of glowing signs and secret messages. Their ability to see ultraviolet light reveals patterns on flower petals called nectar guides, which are completely invisible to us. These patterns act like neon arrows on a runway, guiding the bee directly to its sweet reward. But their most impressive feat is navigation. A bee's compound eye is exquisitely sensitive to polarized light. Sunlight, as it scatters through the atmosphere, creates a distinct pattern of polarization across the entire sky. Bees can read this pattern like a celestial map, allowing them to pinpoint the sun's location with incredible accuracy, even on a completely overcast day. This gives them an unfailing internal compass, guiding them back to the hive from miles away. And while bees are out during the day, the humble moth has perfected the art of seeing in the dark while staying hidden. Its superposition eye is brilliant at gathering faint starlight, but it has another trick that is pure genius. The surface of a moth's eye, when viewed under a powerful microscope, isn't smooth. It's covered in a grid of microscopic, cone-shaped bumps arranged in a perfect hexagonal pattern. This texture, known as a corneal nipple array, is a natural anti-reflective coating. When light hits the surface, instead of bouncing off and creating a telltale glint for a predator to spot, it gets trapped within the nanostructure and absorbed. It makes their large, sensitive eyes almost perfectly black and non-reflective. This piece of natural nanotechnology is so effective that human engineers have copied it to create everything from less reflective glasses and camera lenses to more efficient solar panels and phone screens that you can actually see in bright sunlight. That is biomimicry at its absolute finest. Can you think of any other human inventions that were directly inspired by an animal? Drop your best example below. Of course, sometimes it's not what the eye is made of, but where it's put. And nothing illustrates this better than the utterly bizarre stalk-eyed fly. Just as the name suggests, their compound eyes are perched on the ends of long, rigid stalks that extend horizontally from their heads. In some species, the eye span can be wider than the fly's entire body. This isn't for a wider field of view, but is one of nature's most extreme examples of sexual selection. Females simply prefer males with the longest, most impressive eye stalks. It's a handicap principle in action. If a male can survive and fly effectively while burdened with this ridiculous headgear, he must have superior genes. It's the insect equivalent of driving a flashy, impractical sports car. But if the stalk-eyed fly is about fashion, the ghost crab is all about function. They also have eyes on stalks, but they've turned theirs into biological periscopes. These stalks can swivel a full 360 degrees, allowing the crab to scan the entire beach for gulls from above or for incoming waves, all without moving its camouflaged body a single inch from its burrow. The truly incredible part, however, is that their eyes are bifocal in a way we can barely comprehend. The individual ommatidia are structured differently across the eye. The upper part of the eye has lenses and receptors optimized for seeing clearly in the air, while the lower portion is perfectly adapted for the optics of seeing underwater. This allows the ghost crab to sit at the water's edge and have perfectly sharp, clear vision in both the aerial world and the aquatic world at the exact same time. An eye that can see perfectly in air and water at the same time is just incredible. If you were designing your own super eye from scratch, what's the one feature you would absolutely have to include? Let me know what you're thinking. These multifaceted marvels show us that there isn't just one way to see the world, but an infinite number of ingenious solutions, each one a window into a completely different reality. We've journeyed through a world painted in ultraviolet, slowed down time with the flap of a wing, and peered through the eyes of nature's most incredible hunters. But our grand tour of vision isn't over yet. We've saved the true masters, the ultimate visionaries, for this grand finale. So let's dive right back in, starting with a creature that turns vision into a precision weapon. Meet the archerfish. This aquatic marksman has eyes positioned to give it excellent binocular vision, but that's not its real trick. It hunts insects resting on leaves above the water's surface by spitting a jet of water with phenomenal accuracy. Now think about that. When you look at a straw in a glass of water, it looks bent, right? That's light refraction. The archerfish has a brain that acts like a supercomputer, instantly calculating the exact angle of refraction to correct its aim. It sees the real position of its target, not the refracted image, allowing it to nail a bug from several feet away. It's like having a PhD in physics just for lunchtime. Speaking of seeing above and below the water, what if you could do both at the exact same time? Well, the four-eyed fish, or anoleps, has that covered. This fish doesn't actually have four eyes, but its two eyes are a marvel of biological engineering. Each eyeball is split into two distinct halves, separated by a band of tissue. It swims right at the water surface, with the top half of its eyes scanning the air for predators like birds, while the bottom half scans underwater for food or threats. Each half even has a different lens shape and retinal thickness, perfectly optimized for seeing in either air or water. It's the ultimate bifocal, allowing it to live in two worlds at once without ever missing a thing. From the water's surface, let's take to the air, where one of the planet's most ancient and effective predators reigns, the dragonfly. Its two compound eyes are so enormous, they take up almost its entire head, containing up to 30,000 individual lenses, or ommatidia, in each eye. This gives them an almost 360-degree field of view. But their real superpower is processing motion. A dragonfly's brain processes visual information so rapidly that it perceives the world in slow motion, like a real-life action hero. This allows it to calculate the future position of a flying target, intercept it with deadly precision, and snatch its prey mid-air, all in the blink of a human eye. Now, if a dragonfly is an F-22 Raptor, then the chameleon is a silent, all-terrain surveillance drone. We all know their eyes can move independently, a classic party trick of the animal kingdom. But this gives them the ability to scan a full 360 degrees without even moving their head. One eye can look forward for prey, while the other watches its back for predators. But here's the jaw-dropper. When a chameleon spots a tasty insect, it locks both eyes onto the target, instantly switching to powerful binocular vision for depth perception. Its eyes then do something remarkable. The lens rapidly changes shape to magnify the image, essentially acting like a telephoto lens on a camera. It zooms in on its victim right before launching that famous lightning-fast tongue. It's a master of disguise with built-in binoculars. Let's head back underwater to find a creature whose vision is a beautiful, confounding paradox: the cuttlefish. These masters of camouflage have bizarre, W-shaped pupils that help them see in a wide range of light conditions. But their true gift is seeing polarized light better than almost any other animal. They can detect the finest differences in the polarization of light, which helps them spot transparent prey or communicate with other cuttlefish through patterns on their skin invisible to us. And here's the paradox. Despite being able to perfectly match the color of any background they sit on, cuttlefish are completely colorblind. They see the world in monochrome. Scientists believe their unique pupils and polarization sensitivity allow them to perceive contrast and texture with such incredible detail that they can figure out the color of an object without actually seeing the color itself. Imagine being the world's greatest painter, but only ever seeing in black and white. If you could borrow one animal's vision for a day, which would it be, and why? Let me know your super sight choice down in the comments. From one master of strange sight to another, let's talk about the pistol shrimp. Often overshadowed by its cousin, the mantis shrimp, the pistol shrimp has its own incredible visual system. Its eyes are perched on stalks and can move independently, giving it a wide field of view to spot both prey and predators in its complex reef environment. This keen eyesight is crucial because its weapon isn't about precision strikes from afar, it's about close quarters combat. When it spots a target, it snaps its oversized claw shut so fast it creates a bubble of air that collapses with a powerful shockwave. The vision is what allows it to aim this sonic blast with pinpoint accuracy, stunning its prey instantly. But what if you didn't just have two eyes? What if you had 200? Say hello to the scallop. These mollusks have a row of up to 200 tiny, bright blue eyes lining the edge of their shell called the mantle. These aren't simple pinhole eyes either. Each one is a complex reflector eye, working more like a telescope than a camera. It has a concave, mirrored layer at the back that focuses light onto two separate retinas. One retina is fine-tuned to detect light and shapes, while the other is specialized for detecting motion and dark, looming shadows, like an approaching starfish. This early warning system gives the scallop a chance to clap its shells together and jet propel itself to safety. From an animal covered in eyes, we move to one that sees in a whole other dimension of reality, the pit viper. Snakes like rattlesnakes and copperheads have a superpower that borders on the supernatural. In addition to their normal, functional eyes that see the visible world just like other vertebrates, they have a pair of special organs called pit organs, located between their eyes and nostrils. These pits are incredibly sensitive heat detectors. They can detect temperature differences of as little as 0.1 degrees Fahrenheit, 3 degrees Celsius. This information is sent to the same part of the brain that processes visual information, effectively allowing the snake to see an infrared heat map of its surroundings, perfectly overlaid on its normal vision. In total darkness, a warm-blooded mouse would glow like a neon sign, making escape completely impossible. This idea of seeing invisible forces brings us to one of the greatest mysteries of the natural world: avian navigation. For decades, scientists have wondered how migratory birds, like the European robin, navigate thousands of miles with unerring accuracy. The answer, it seems, is that they can literally see the Earth's magnetic field. This theory, called magnetoreception, suggests that when a photon of light enters the bird's eye, it triggers a quantum chemical reaction in a protein called cryptochrome. This reaction is sensitive to the angle of the Earth's magnetic field, creating a visual pattern that is superimposed over the bird's normal vision. In essence, they might see the magnetic field as a pattern of light or shade across the sky, providing them with a constant, reliable compass no matter the weather or time of day. They aren't just looking at the world, they're seeing the fundamental forces that shape it. And for our final look into the world of super eyes, we come to a creature that shouldn't even be able to see at all: the box jellyfish. This gelatinous drifter has no brain, just a simple nerve net. And yet, it possesses 24 eyes, grouped into 4 clusters called rhopolia. These aren't just light-sensing spots. The 4 different types of eyes have varying complexities. Some are simple slits, but others are remarkably sophisticated, complete with lenses, retinas, and corneas, much like a vertebrate eye. These advanced eyes are always pointed upwards, allowing the jellyfish to navigate the complex mangrove swamps it calls home. It can spot and steer around obstacles, gauge the water's depth, and stay in the shade where its tiny prey gathers. It's a visual navigation system so complex it seems to defy its simple biology, proving that even without a brain, sight can find a way to create a window to the world. From the physics-defying aim of the archerfish to the quantum compass in a robin's eye, we've seen that vision is so much more than just seeing. It's a story of survival, of evolution's endless creativity, and of 100 different ways to perceive a single reality. The world is filled with wonders that are hiding in plain sight, and all we have to do is remember to look at it through another set of eyes. Thank you for joining me on this incredible journey. If you enjoyed exploring the amazing world of animal vision, be sure to hit that like button and subscribe for more deep dives into the wonders of nature.